Hello and welcome to Honors Function. This is the third lecture on graph transformation. There are no new results in this lecture, only some applications. So let's begin with the first example. Alright, so you have to describe the sequence of transformation from f to g. Okay, so this is I call it sometimes the mother function. It's often called the parent function. There is no official name for it. It's a function you are transforming. It's a very simple function and it becomes a little bit more complicated. Okay, so how do we do that? Well, we'll need to change the way this function is written. You have to change the expression, and this is what you will often have to do in the example I'm giving you on class assignment 30. Okay, all right, so how do we change it? Well, let's rewrite it. So g of x equals negative 2x squared minus 6x plus 1. Well, I'm going to complete my square and change the quadratic term and the linear term and transform it into a square, right? And that's going to be this square right here. So you know what to do. Let's divide by, so if and only if, I'm going to divide by negative 2. G of x over negative 2 equals, so it is x squared plus 3x minus 1/2. Then here I'm going to complete my square. X plus 3/2 squared minus 9/4. So let's get the common denominator here right away, minus 2/4. So this is negative 11/4. Let's get back the negative 2. So we have that g of x is equal to negative 2 times x plus 3/2 squared minus 11/4. So now I should be able to state the sequence of transformation from y equals x squared to y equals this function right here. Let's do it. So let's first begin with y equals x squared. Y equals x squared. And then where do you go? So I'm going to call this one number 1. We're going to have to be careful. Not only I want you to be able to write it correctly, but I also want you to use the correct terminology, okay? So it goes to y equals x plus 3/2 squared. That's a horizontal translation. It's on the x-axis. I'll write it after. Number 2. What's number 2? So now we take care of the 2. Be careful, you got to break down the negative sign and the 2, right? So it is y equals 2 times x plus 3/2 squared. Next one, what do we have? Well, now we have the negative sign. So number 3, y equals negative 2 times x plus 3/2 squared. And finally, the last one is, so it's a vertical translation, y equals, so negative 2 x plus 3/2 squared minus 11/4. That's how I go from f to g. So now it's time to write what they are. So number 1, it's a horizontal translation. Okay, the word is translation. Sometimes you can use shift if you want, horizontal shift. But translation is more accepted. 1.5 units, and you have to tell me where. 1.5 units left. Okay. Number 2, we're done with the input. Number 2 is in the output. It's a vertical dilation by a factor of 2. All the y's get multiplied by 2. Number 3 was the negative sign in front. Number 3 is a reflection. We don't write vertical or horizontal here. We specify around which axis. Reflection across. So y becomes negative y, right? So y becomes negative y across x axis. Okay. And finally, number 4. So number 4 was this one right here. So number 4 is is a vertical translation. 11. Oh, did I make a mistake? I think I may have. Yep. When you multiply this one by 2, it becomes, oh my gosh, this is really off here. It becomes plus 11 half. Sorry about that. Okay, so it's a vertical translation. So here, let's use a decimal. It's going to be more telling. It is 5.5 unit upward. Upward. Okay, that's it for this example. Please do the next one, and I'm going to do the third. All right, so now you want to go from this function to this one. In this case, I don't need to change the way it's written. I understand it perfectly. I mean, I could write maybe -2 cube root of 3x plus 5 and put the 1 on the other side. This is the way I present my result, but it's pretty clear like that, okay? So, let me first describe it with the different expression. So the cube root is a parent function, and what happens to the input? So number 1 is y equals cube root of x plus 5. Okay, that's number 1. Number 2 is y equals cube root of 3x plus 5. You know that number 1 and number 2 are not switchable. You cannot interchange them. Okay. Number 3, it's y equals 2 cube root of 3x plus 5. Number 4 is y equals -2 cube root of 3x plus 5. And finally, the last one, number 5, it's y equals -2 cube root of 3x plus 5 plus 1. Okay? So, let's describe them in plain English. Number 1 is the horizontal translation, 5 units left. Number 2 is a horizontal. Now, you see 3x, so you want to dilate, but in fact, you're going to compress. It's a horizontal compression by a factor of 3, meaning all the x coordinates get divided by 3. Okay? Number 3, I'm done with my input. It's about the output. It's a vertical dilation by a factor of 2. Okay. Number 4, almost done. Number 4 is a reflection across, so y becomes -y, so across the x-axis. And number 5 is a vertical translation, 1 unit upward. Okay, that's it. So please do number 5. There is one more example. I'm going to do one of the 2 questions in the last example. So we have question 5 and question 6 all about this graph. Now, absolute value around the output or around the input are not some sort of specific graph shifting, but they're pretty common, they're pretty well known, and you need to know how to do them. They're very simple actually, and they're kind of interesting too. So I want to graph g of x. In red, I have the graph of f of x. So to do that, we need to know what the absolute does, right? So remember the definition of the absolute value. Absolute value of a is equal to a if a is positive or equal to 0, and the opposite of a if a is negative or equal to 0. Or I guess I should say negative. It doesn't matter. Okay? All right. So how can that help me? Well, if f of x is positive, the absolute value is just itself, right? So where is f of x positive? F of x is positive right here, and f of x is positive right here. So g of x is going to be equal to f of x. Here, let me write it here. So g of x is equal to f of x if f of x is positive, right? Because g of x is the absolute value of f of x. And the opposite of f of x if f of x is negative. That's it. And you know how to take this transformation here, right? It's a reflection across the y-axis. So let's just do it. So when x is positive, f of x, g of x is equal to f of x. So this is a graph of g right here and right here, right? Because f of x is positive there. And when f is negative here, here, and here, g of x is the opposite of f of x. So it's reflected across the x-axis like that, and like this. Here we go. So in blue we have the graph of y equals the absolute value of f of x. So this is when the absolute value is on the output. I'll let you figure out what happens when the absolute value is on the input. Okay? Thank you for watching.